Alright, let me give you the history of my productive struggle here. I looked at this equation, 9x squared plus z squared is equal to 16, and I was trying to come up with a description of the solution set to it, and I thought, ellipse, duh. But then I remembered, we're probably supposed to be doing this in 3 variables, and so, of course, the textbook, made it kind of context dependent here, right? There is no there is no there is no y in that equation. So if you're going to have an equation in 3 variables, you need to explicitly say the algebraic equation in 3 variables so that people know that there's supposed to be some other third variable. I put that in there just to remind myself. Okay. So in particular, that determines that solutions are ordered triples, meaning that each solution is a point in a 3-dimensional space, like this point right here, this green point and this other green point. Those are points in 3-dimensional space. And they would just be in 2-dimensional space if it was an algebraic equation in 2 variables. So that 0 times y actually carries a lot of information. And I got a bit of a problem with the textbook authors on their ignoring that problem. So, and then I go on to say that has the same shape for every constant y coordinate, of course, because it has a 0 times y in it, or you could equivalently say it doesn't have a y in it. And that shape is an ellipse with eccentricities 4/3 and 4. So I drew that. I drew the XYZ coordinate system, and then I started drawing the eccentricity 4/3 in the z direction, because I just was kind of obsessed with the z direction apparently. And then I abandoned that, stopped using blue, and instead drew 4/3 along the x-axis in red. And so 4/3, that's a little bit bigger than 1, so I went out to 2 and then went a little bit bigger than 1 there, and then eccentricity 4 in the z direction. So as you can see, I have made yet another mistake. So let me X that out, scribble that out, circle that, and say never mind. Okay, I got to start over with the drawing. I'll make a coordinate system, and I will continue to use the x, y, and z orientations that we used most often, but this time I want to be careful as I draw the eccentricity 4/3. That's here in the x direction. So in the x direction, 4/3. There's 1, there's 2, here's about 4/3. Go back a bit. Here's 1, here's 2, here's about 4/3. Good. Now the eccentricity 4 is in the z direction, and so I need to draw 1, 2, 3, 4 in the z direction going down. I'll also do 1, 2, 3, 4, and I need this point and this point right here, and I should be able to draw some kind of an ellipse that goes through all of those. I'll do it in green again. Actually, I think blue shows up better, so I'm going to switch to blue. And so my ellipse will come up like this and go down like this. Now, the back half of that ellipse, right, that's probably going to be covered up by some surface, so in anticipation of that actually being covered up, I'll draw it dotted, if YouTube's resolution can, well, pick that up. Okay, and so that's the same shape that you get when y is 0 or y is 53. So I will extend this off into the side and draw the same shape again over here, some larger y coordinate, and I will extend the shape off this direction. And now I have the picture that this axis is in front of the front of that line, right in front of my shape. So I may have that picture in my head, is what I'm trying to say. Now over here, I will draw another ellipse of the same shape. Try to get the same shape. Okay, and that is a tube, right? An elliptic cylinder that goes this way, and it is taller than it is deep. You can see that. Height of 4 right there and a depth of just 4/3. Okay, so it can be a struggle getting these things drawn the right way every time. In a sense, you could say it doesn't matter. The shape is the same as the shape, just sort of rotated. But I wanted to get the correspondence between the variables here and the label of the coordinate axes over here correct. And thanks for coming on that adventure.